Hello everyone, I would like to share the answer for question number 8 for circular measure module Cemerlang. So we look the question first. Diagram 8 shows two circles centered at O and P with radius R, capital letter R and small letter r. The two circles touch each other at point C. So this you have two circles. So before we go into the question, you can label it. The radius is already labeled. Okay, please label. Okay, you draw a straight line to form a right angle triangle and label it as A. Same as for this, the second circle. You form a right. You draw a straight line to form a right angle triangle and label it as A also, because both lines have same length. Then from the centered O for the big circle, from centered O until the straight line, you label it as B. Then from the straight line here, from the point of this straight line until the circumference, you label it as C. Okay, same goes for the small circle from the center until the straight line. We label it as B, and from the point of straight line until the circumference, we label it as E. Okay, after this, it is given that the AB and OCP are parallel. Okay, AB and OCP are parallel. So the first question shows that R over R equal to square root 6 over 2. So from here, why I ask you to draw a straight line, you can form a right angle triangle, so you can use the trigo here. So from the big circle here, okay, you use the trigo. Sine pi over 4 equals to opposite length is A over hypotenuse is the capital R. So after you from here you find what is R. Your R is A over sine pi over 4 is 1 over square root 2. So will be equal to square root 2A. Same goes to the small circle here. Sine pi over 3 will be equal to the opposite length A divided by the hypotenuse, that is small letter r. So from here we find what is our r. This is equal to A over pi over 3. You can take pi as 180. 180 over 3 is 60. Sine 60 is a square root 3 over 2. So it will become 2A over square root 3. Then we take r divisible by r. So here the capital R is square root 2 over square root 2A over 2A square root 3. So this square root 3 times with square root 2 will become square root 6 over 2. A and A you can cancel it. So the answer we already show that square root R, capital R over small letter r equal to square root 6 over 2. Then we go to the next question, part B. Given area of sector OAC over area of sector BPC equal to K, find the value of K. So first we find the area of OAC here, the sector, that means we use the formula half r square theta. So half r capital letter R square over pi over 4 over area of sector BPC. So the small for the small circle, still same, use the same formula. Half r here, radius is the small letter r square, theta is pi over 3. So equal to, okay, we come back here, half and half we can cancel it both. Okay, half and half, we can cancel it. So here you will have r square pi over 4. Okay, r square over r square, we already show in the first part A, that r over r is square root 6 over 2. So we square it, r square over r square, so we get square root 6 over 2 square. Then pi over 4 divisible by pi over 3, so since it's a fraction, we change it to multiply. So pi over 4 multiply with 3 over pi. So pi and pi also can cancel it. So here square root 6 square, you get 6. 2 square, you get 4. Times with 3 over 4. So you will get 9 over 8. So the value of k is 9 over 8. Next, we go to the part C. If r equal to square root 12, capital letter R equals to 12, square root 12, find the area of the shaded region in centimeter square. So your answer should be a radical form. Okay, that means we don't want any answers in decimals or fractions. So this is the type of radical form here. So the same thing, that's why for what I asked you to label B, C, D, and E for this part, for part C. So why I want to, my main idea, we want to find the shaded region. You want to find the shaded region here, you have to take the whole trapezium. You can see this is the trapezium shape. You have to minus with the sector of OAC and area of sector of BPC. That is the idea. So you want to find the area of the trapezium. You need the length of AB and also OP. That's why we find B, C, E, D here. So we want to find B. Before that, we find A first. Okay, how to find A? That is the opposite length. Okay, since sine pi over 4 equals to A over opposite over hypotenuse. So opposite A. So sine pi over 4, we know that's actually sine 45. 180 divisible by 4 is 45. So you get 1 over square root 2 times with capital letter R is actually equals to square root 12. It's already given in the question. So A, we get square root 6. Then we find B. The same thing, we use cos. Cos pi over 4 equals to B over R. So half times square root 12. Cos pi over 4 also 1 over square root 2. Then times with square root 12. So B also you will get square root 6. So how we want to find C? C, we take the whole thing is actually radius OC here, radius. So the radius is square root 12, so minus with B square root 6. Or you can write it as 2 square root 3 minus 6 also can. Then for the small circle now, sine, okay, we find the R first. What is our radius? Okay, what is the purpose? Just now we find A, we want to use to find the small letter R here, the radius here. That's why we need A just now. So sine pi over 3 equals to square root 6, that is A, opposite over hypotenuse. So from here we solve, okay, sine pi over 3 is actually 60 degrees. Sine 60 is square root 3 over 2 equal to square root 6 over R. So R is square root 6 times 2 over square root 3. So you get 2 square root 2. Okay, from here you find the value of D and E. So D is here. We take cos pi over 3. Okay, that is cos 60 equals to D over 2 square root 2. The R is 2 square root 2. Adjacent over hypotenuse. So D we get square root 2. Then E is the radius R here. minus d. So radius 2 square root 2 minus square root 2, you get square root 2. That means 2 minus 1, no? 2 minus 1, you get square root 2. Okay, from here we find the area of trapezium minus this area of a sector OAC and area sector of BPC. So area of a trapezium, there's half times with sum of parallel lines. So sum of parallel lines, that is square root 12 minus square root 6, this one, the C plus square root 2 E, C plus E, that is AB here. C plus E is the AB here. Okay, square root 12 minus 6 plus with square root 2 plus with, okay, this whole thing R plus the small letter r here. So square root 12 plus with 2 square root 2. Okay, sum of parallel lines. So this is sum of parallel lines. Square root 12 minus 6 plus square root 2 is AB. C plus E. Okay, C plus E. Plus with capital letter R plus with small letter r. So this is sum of parallel lines times with the height of the trapezium. This one. Just now we find A, square root 6. So minus with the area of a sector, half r square theta, half square root 12 square, theta is pi over 4, plus with area sector of BPC, half 2 square root 2 square pi over 3. So this is half r square theta. So now we just solve this. So square root 12 plus square root 12, you get 2 square root 12. Plus with square root 2 plus with 2 square root 2, you get 3 square root 2 minus square root 6 times with square root 6. This is for trapezium. Then here we solve square root 12 square, you get 12 divided by 2. You get 12 divided by 2, you got 6 over 4, that's 3 over 2 lah. After we simplify, 3 over 2 pi, plus with the other side, half 2 square, 4 times 2 is 8, divide by 2, you get 4, so 4 over 3 pi. Okay, we simplify this, you get 4 over 3 pi. Okay, now we simplify the trapezium first here. So square root 12, you can simplify some more because 12 comes from 4 times 3. So 4, you can square root, becomes 2. So you get 2 times 2 here, 4. Okay, so 4 square root 3 plus with 3 square root 2 minus square root 6 times with square root 6. So here we solve 3 over 2 pi plus 4 over 3 pi is a 17 over 6 pi. Okay, now we expand, we times with square root 6. So we get 4 square root 18 plus 3 square root 12. Square root 6 times square root 6 minus 17 over 6 pi. Now we again expand with times with half. So 18. 18 comes from 9 times 2. 9, you can square it, you get 3. So this 4, you cancel it, you get 2. 2 times 3, 6. That's why you get 6 square root 2. Then here, 12. 12 comes from 4 square root 3. Okay, 4 square root 3. Sorry, so 4 times 3. 4 times 3, so 4 you can square it. So you get 2. So that 2 and this 2 cancel, that's why you get 3 square root 3. Then 6 divisible by 2, you get 3. Minus 17 over 6 pi. So this is the answer in radical form. So this is the answer for question number 8. So I hope you all understand.